Hi everyone, thanks for coming to this session. In this presentation, I'm Fajri, one of the authors. We'll talk about the first large-scale dataset for summarization in Indonesian language. In this paper, we gather roughly 200,000 article and abstractive summary pairs and train some neural models to create the strong baselines for the corpus. This is a joint work with Jehan Lau and Timothy Baldwin from the University of Melbourne. Indonesia is a country in the Southeast Asia region. With population more than 270 million, it makes Indonesia as the fourth most populous nation in the world. Most of people in Indonesia is bilingual, speak the local language and Indonesian. According to some statistics in the internet, there are roughly 200 million Indonesian speakers today. However, this language is underrepresented in deep learning research for NLP. One of the critical reasons is the scarcity of large corpus for a different range of tasks. And in this work, we initiate to tackle this problem by introducing a suitable summarization corpus for supervised abstractive and extractive models. First, let's take a look to neural summarization in English. Before year 2015, NYT and GigaOut corpus are introduced, and in 2015, Rush et al. Is the first work on neural summarization where he applied attention mechanism on training GigaOut data. In the same year, Herman et al. Released CNNDM, a corpus with size 320K summary article pairs that later becomes one of the most favorite datasets in abstractive summarization. In 2016 and 17, the pointer generator network is introduced and becomes one of the standard baseline in the current research. The emergence of pre-trained language model also result in strong models such as BERT and Pegasus in 2020. Another corpus is also released lately, such as Xtreme, Archive and PubMed, Big Pattern, and Reditivo data. Research on neural summarization has been centralized in English. At the time this work was conducted, there are only two large-scale non-English corpus. The first one is LCSTS, a Chinese corpus constructed from local microblogging Sinawibo, and ES News, Spanish corpus that is not publicly available. Early research on Indonesian text summarization has been extractive and used very small data, for instance, Gunawan et al. 2017 and Najibullah 2015. Previous attempts have been also made to construct a standardized summarization corpus in Indonesian language. Koto 2016 created a dataset for chat summarization by manually annotating chat logs, while Kurniawan and Lovan 2018 introduced IndoSum, where they collect and manually annotate 19K news. IndoSum is a good start of neural summarization in Indonesian language. However, based on our early analysis, IndoSum is highly extractive, making it less suitable for abstractive summarization. Now, let's take a look on how we create the first large-scale Indonesian summarization corpus, Liputan6. Driven by the success of CNNDM in English summarization, we initiate the data collection for Indonesian summarization in the same domain, news article. As you can see in the slide, Liputan6.com is an online Indonesian news portal launched since August 2000 and provides news in a wide range of topics. The site continuously produces daily articles and provides a short description for RSS feed purpose. We use this short description as the summary. We harvest Liputan6.com articles that are publicly available in 10 years time range between October 2000 and October 2010. We process them as a large summarization corpus comprising 215K pairs of document and summary. In total, Liputan6 is 11 times larger than IndoSum and comprises of shorter article and summary in average. In this table, we provide second comparison of IndoSum and Liputan6. This table reveals that Liputan6 consistently has lower row score R1, R2, and RL for lead, and significantly has higher percentage of novel engrams. This novel engram is calculated relative to the source document, which indicates that the gold summary of Liputan6 is more abstractive than IndoSum. Inspired by Xtreme corpus, Narayan et al. 2018, we also construct a validation and test set where the summary is extremely abstractive. We filter the main validation test set with the novel 4 grams greater than 90% to create an extreme test set. while the training set is remaining the same in this test, in this cluster. Now let's take a look on the summarization architecture we use to create the strong baseline. We employ multilingual BERT as our pretend encoder for training extractive and abstractive models. We also conduct experiment with IndoBERT, the Indonesian version of BERT that we train in our server. We follow summarization framework by Liu and Lopata 2018, where we alternate BERT utilization to accommodate multiple sentences representations. We use the same trick with Liu and Lopata 2019, where we insert tokens TLS and SAP for every sentences. And to distinguish sentences, we apply two-segment embedding, TA and TB, based on odd or even order of a sentence. IndoBERT is trained by using Hugging Face framework. As you can see in the slide, we train the IndoBERT with Wikipedia, news article, and Indonesian web corpus. We train with more than 1 million instances and achieve perplexity similar to English BERT. For extractive model, on top of BERT, we use route transformer encoder to learn intersentential relationship. A simple binary classification is performed for each sentences to predict the extractive summary. We automatically estimate the extractive labels by greedily optimizing Roach-1 between subsets of the article and the gold summary. We call it as oracle, denoting the highest bound of the extractive summarization performance. For abstractive model, we use route transformer decoder on top of BERT to learn summary generation. We denote this model as BertExtAbs. Lastly, we conduct the third experiment, denoting it as BertExtAbs. It's kind of like the incorporation of the extractive and the abstractive model. Let's move to the experiment result. In these presentations, the experiment results are presented in Roach-1 score. Please refer to the paper for other scores such as R2, RL, and BERT score. First, we observed that lead 2 is the best lead for Liputan6. This is in line with the previous finding, where the average number of summary sentences is 2. The scores decrease significantly in Xtreme Dataset, indicating that Xtreme set is a harder summarization task with a higher level of abstractiveness. In the second result, we observed that pointer generator network, the red bar, performed worse than lead 2 for canonical and Xtreme Dataset. And for multilingual BERT models, overall, either extractive or abstractive model, they perform very well. The model gains improvement by 3 points from the lead. The best performance is mostly achieved by BertExtAbs with IndoBERT model for both datasets. In Xtreme dataset, the performance dropped for 6 to 7 points from the main set, even though it still achieved the best summarization performance within the Xtreme dataset. It's also worth to mention that in this experiment, we show another empirical result where multilingual pretend language model has not been able to surpass the monolingual pretend language model. In this section, we provide a thorough error analysis against the extractive and abstractive model. First, we provide analysis for extractive model, or BertExt, and in this figure, we describe that the extractive model, the red bars, tend to classify the first 2 sentences as the summary and causes a large disparity with oracle or gold summary, especially for sentences in position 1 and 2. In these distributions, BertExt predicts 65% extractive summaries in the position 1 and 2, while there are only 42% oracle sentences in this position. We might argue that the model prediction in this dataset is due to the distribution in the training set. However, if we look at the training distribution, there are also 43% of extractive summaries in the first 2 sentences, which means similar to the dataset. Next, we perform error analysis for BertExtAbs model. First, we found that there are 5K documents with Roach-1 less than 0.4, and we create 100 random samples from this cluster for further analysis. As the first step, we asked 2 native Indonesian speakers to manually evaluate this sample by annotating them into bad, average, and good category. Our annotators achieved Pearson correlation score 0.692, indicating a moderate positive correlation. After grouping the summary into bad, average, and good category, we carefully analyzed them by examining these attributes. whether the system summary contains abbreviations, morphological variations, synonyms, lack of coverage, wrong focus, and unnecessary details that are from document or not from document. Particularly for abbreviation, we check whether the system summary use abbreviations that are different to the reference. In this table, we show the complete result of our error analysis. The first observation is more than half, around 60% of our samples are actually annotated as a good quality. The primary reasons of relatively low root scores are 86% paraphrasing and 75% uncritical, unnecessary details. The bad system summary have primary issue with capturing essential contents, where the percentage of coverage problem and unnecessary details are the highest, around 90.6%. Lastly, also worth to mention that around 68% of bad summaries create different nuances due to the wrong focus aspect. In these snippets, we show example in our error analysis where the system summary is considered as a good one, but have low root score. First, in this example, the gold summary contains an abbreviation Kemenakertrans, while the model generates the full form Keputusan Menteri Tenaga Kerja dan Transmigrasi, or in English, Minister of Manpower and Transmigration Decree. We also notice a different morphology between words tuntutan and menuntut are used in the goal and human summary. Finally, this is our primary contributions on this research. First, we released Liputan6, a large-scale Indonesian summarization corpus, additionally with the Xtreme variant. Second, we create strong baseline with IndoBERT model. And lastly, we perform a thorough error analysis. Thank you for your attention. The data will be publicly available in my GitHub account. According to Indonesian copyright law, chapters 14 to 18, the utility of this corpus is limited to non-commercial activities, but the law fully permits the corpus utility for education, science, and research activity.